How can we distinguish slippery elm from the other soft elms? And which features do we rely on to differentiate slippery elm from hackberry? I'm Frank Owens from the Wood Identification Team at Mississippi State University. In this series of videos, we'll teach you how to identify North American woods the scientific way, with a small magnifying glass called a hand lens. In video number 7, we taught you how to identify two of the three elm groups, American elm and the hard elms. If you've not watched video 7 already, I recommend doing so to be clear on the distinction between hard and soft elms. In this video, we'll teach you how to identify the other soft elm group, represented by slippery elm, and compare it to a look-alike hardwood called hackberry. Though structurally similar to elm, hackberry belongs to a different genus called Celtis. Like elm, hackberry is not as popular as red and white oak. Similar in weight and hardness to the soft elms, hackberry can be used for furniture as well as a substitute for other woods. As we suggested in the previous videos, please remember when you view your wood specimens under a hand lens to orient them with the rays running vertically and the growth rings running horizontally. This will make it easier to compare them to the images you see in my slides and your wood anatomy reference book. All references to vertical and horizontal in my videos will assume the same ray and growth ring orientation as in the images. We'll see many features of slippery elm and hackberry today, but let's start by previewing the most important ones, the ones you should commit to memory. We'll start with the features that these two woods share. Both are ring porous and have multiple rows of early wood pores. Additionally, like American elm and the hard elms, they both have horizontal, that is tangential, wavy bands of pores in their late wood. As we mentioned in the previous video, the elms and hackberry are the only North American commercial hardwoods that have wavy tangential pore bands. As for contrasting features, there aren't many. Macroscopically, there's only one, heartwood color. There's another more reliable way that involves a microscope, but we won't cover that here. Keep these lists of most important common and contrasting features in your mind as we look at these and other features in detail. Now let's look at some images and compare slippery elm and hackberry. We'll start with a shared physical characteristic. Both woods are of medium weight and hardness, just like other soft elms. Moving on to color, the heartwood of slippery elm is similar to the other elms, light brown to brown with a reddish tinge, while the color of hackberry is light brown to grayish brown with a yellow cast. This color difference is the main way to distinguish slippery elm from hackberry without a microscope. Next, let's look at some anatomy. We'll start on the tangential surface. Both slippery elm and hackberry have what we call uneven grain. That means you can clearly see a visual contrast between the early wood and late wood on the tangential surface. Now let's move to the radial face. While you might notice some ray fleck in both images, the flecks are not big and prominent like we saw in the oaks, so there really isn't much to remember on the radial face. Finally, let's look at some transverse features. Both woods are ring porous. And both slippery elm and hackberry have larger early wood pores in continuous rows. This feature contrasts with the small pores of discontinuous rows in the hard elms. The third common feature is the multiple rows of pores in the early wood. These multiple rows of early wood pores are an important diagnostic feature that separates slippery elm and hackberry from American elm and the hard elms, which exhibit a single row. The final common feature is wavy horizontal or tangential late wood pore bands. Remember, this is the feature that separates elms and hackberries from all other North American commercial species. The differences between the three elm groups in hackberry might be challenging to recognize at first, but the more images and samples you look at, the easier it will become to separate them. To summarize, let's organize all these features into a table. While all these woods exhibit a ring porous structure and wavy tangential late wood pore bands, they differ in the following ways. Hard elms are the only group with smaller early wood pores in a single discontinuous row. Slippery elm and hackberry stand out as the two groups with multiple early wood pore rows. And finally, hackberry can be differentiated from the elms by the difference in heartwood color. While elms tend to be brown to reddish brown, hackberry has a yellowish cast and can have some grayness to it. And that's all, folks. Congratulations on identifying two new hardwoods. Now that we've finished the oaks, the elms, and hackberry, we're going to increase the difficulty just a little bit next time by learning another important feature of hardwood identification, parenchyma. We'll need to know about parenchyma patterns to identify the woods we'll introduce after that. If you're interested in learning how to identify wood the scientific way, please like this video and subscribe to our channel. We'll be rolling out new videos over the next several weeks. In the meantime, if you have a wood specimen you want scientifically identified, or in-person or online training for yourself or your company, please send me an email at frank.owens@msstate.edu. This video has been brought to you by Mississippi State University Extension, taking care of what matters.